Yes.
So, okay. So
Yes, sir.
most welcome. Good afternoon and welcome, my dear participants, professors. Most of them I have heard, Professor Mondal, that many of the university and you are also from the academic fields of the engineering colleges lectures. So, my dear participants, I am going to start my presentation. So my topics is today's topics is hazardous waste management. So tomorrow also I have a lecture on the liquid waste. So today I will cover the hazardous waste management. So the contents, first I want to share the content of my presentation. So the contents will discuss introduction or background, then hazardous waste generation in industries, needs of management, then various sources from the industries where hazardous waste generated, possible sources, and how the rules are important with respect to hazardous waste management. Then general characteristics, very important. General characteristics of the, I think you have a separate session of the characterization of the solid waste, I think, but this will give you an idea. In the next session, this will help you, I think. General characteristics of the hazardous waste and type of waste and disposal. Depending on the type of waste, what is the disposal? And generation, and we'll share some ideas about in Indian context, the generation in different Indian states. And then most important aspects is the legal requirements. Legal, because every industry must follow these legal requirements. Then the most latest hazardous waste management rules 2016 under MOEF. We'll discuss this rule, and that's the basics of the what is hazardous for 2016. Actually, it was generated in 1989 and latest amendment made last 2016. Then transportation and storage, then disposal, and because for then analysis, lab facilities to be required for characterization or analysis of the hazardous waste, then some real-life pictures of the management facilities, how the waste are managed, how the waste are transported. So some images, real-life images of the management facilities, then way forward with a conclusion. So this will be our entire coverage with respect to my lectures on hazardous waste management. So in introduction, I just want to say that hazardous waste management is a very important issue in today's environmental perspective and gaining global importance. This is a very important issue. And there was not much progress made until 1995. There was a rule enacted 1989, but not much progress made in respect to hazardous waste management until 1995. Focus is then shifted to developing waste management technologies that actually helpful to recover and conserve our natural resources. Because we'll discuss in later, because the hazardous waste is creating a lot of problems with respect to conserving protection of our natural resources. And without proper destruction or disposal, hazardous waste could be a major source of toxic pollution and threat to our lives and the natural environment. So hazardous waste presents immediate or long-term risks to humans, animals, plants, and the environment as a whole. Okay, so now in Article 5, 51A, G, Section G of the Constitution, one of the fundamental duties of the every citizen of India. See, in Article 51A, Section G of the Constitution, Indian Constitution, one of the fundamental duties of every citizen of India is to protect and improve the natural environment, including forests, lakes, rivers, and wildlife, and to have compassion for living creature. The concern and the serious need to regulate and manage hazardous waste was not realized in Indian industry or Indian perspective until after the Bhopal gas tragedy. All of you were about the Bhopal gas tragedy of 1984. You know that first, after that, the hazardous waste management rules enacted by the Pollution Control Board. So this next paragraph, you can see that after the Bhopal gas tragedy of 1984, this accident focused government attention on hazardous waste management, and subsequently in 1989, see, the Bhopal disaster was 1984. Then in 1989, the Ministry of Environment and Forest of the Government of India promulgated the hazardous waste management and handling rules. So that's why the concern and serious need to regulate the manage and hazardous waste was not realized until and unless this Bhopal gas tragedy was there. So after that, the hazardous waste management rules are enacted by the MOEF, Government of India, as a hazardous waste management and handling rules. It was first 1989. Industry management of hazardous waste by industries. Industry obtain authorization from the State Pollution Control Board for generation, storage, treatment, transportation, and disposal. So entire scheme of the waste management, starting from generation, storage, treatment, transportation, and disposal of hazardous waste. Industry has to obtains authorization, and for authorization, lot of possibilities are there. Once waste are generated, priority is for recovery and reuse of the waste material. Solvent recovery is practiced by almost all industries, solvent recovery. Okay, so one waste are generated. Now, as per the new rules, and every industry also, we have to, and it is guided in the waste management rules also. The priority should be recovery and reuse of the waste material. This should be given the priority. First, you have to find out the recovery and reuse opportunity of the waste material. Then solvent recovery is practiced by all industry, because otherwise, you know, that solvents may create lot of problem with respect to the atmospheric pollution, then wastewater contamination, lot of issues can be created. Solvent recovery. That's why solvent recovery is another issue which is already practiced by many industries. Many useful products, and it has been found by research, or the various now industry, most of the industries are looking for recovery. Otherwise, due to the environmental hazards, environmental concern throughout the globe, not only in India, so many useful products now looking. That's why the research has focused to recover the resources, resource recovery. This term is very important, is now, whether it is a liquid waste or is a solid waste. So resource recovery is the great issue, and it is the major focus. Many useful products are recovered from waste streams. Example, sodium sulfate from mother liquor of chemical manufacturing may be required. Recently, I am associated with a pharma industry in nearby Kolkata, West Bengal itself, where I am working associated with them as an advisor with respect to wastewater treatment facility and also looking for solid waste management. So when one wastewater, they are planning for recycle. You know that apart from waste industries, now water is a big issue, water management, wastewater recycling. So when wastewater is recycling, there is always some solid waste are generated. The last stage, if the plant is looking for ZLD, zero liquid discharge, this concept has come. So with respect to wastewater, and I am deeply involved on this with respect to present wastewater recycling. So I have visited the plant. So presently they are discharging. So they wanted to recover. They have around 100 KLD plant. So nowadays technologies are available where you can recover around 95% of the wastewater. So, but 95% of the wastewater, if you generate, recover, that 5% will contain high amount of solid, which we have to look for. That may be a hazardous waste. That 5% solid may be high concentration of solid, very high solid concentration. It may range from 5,000, 10,000 to up to 30,000 as well, depending on the wastewater characteristics, the matrix, the components present in the wastewater. So see, I am sharing this experience. Once after visiting the plant and characterization, it has been found that here sodium sulfate, it has been found that water contains around 3.6 to 4% of the sodium chloride. 5 to 6% of the sodium chloride. And no other so much of contaminants are there. Major is the sodium chloride. So then we are brainstorming, and it has been found that this sodium chloride can be, obviously the plant management was not so much of aware about that this can be recovered. And because they are now discharging the wastewater, they are not aware about that. So once we go for recycling, once we done that study, that the resource recovery, wastewater recycling by 90% recycling, we have seen that it is possible to recover along with the water that quantum sodium chloride present in the water with a concentration of 3.5 to 6%. So it has been found that the plant can recover per day 300 kg. It is a small plant, but 300 kg of sodium chloride can be recovered. At the same time, they can recycle that out of 100 KLD, 90 ml, 90 KLD water. And that water can be saved from the source itself. At the same time, resource recovery. So sodium chloride, and that sodium chloride can be commercially sold to the market. And you know that sodium chloride is a huge market where it is a sodium chloride major in every industry must have that unit operation, which is known as softener. Softener is a very basic unit operation, which is every industry required for the softening of water softening plant. If you go to the process side, textile, pulp and paper, power plant, any industry, softener is a very common industry. And every softener, you know that softener are used as a cation exchange resin. For softener recovery, you need a sodium chloride for regeneration of the softener resin. So that salt can be commercially sold to the market. It is a pharmaceutical industry. So by brainstorming, by resource recovery, they can sold 300 kg is a resource to resource can be a another raw material to the other industry. So this is the approach. Like sodium chloride, sulfate, I am just sharing you a real life experience. So the plant is already project has been approved, and the plant is immediately going to start that activities, because per day they will generate not only the water recovered, at the same time they can recover the sodium chloride from the wastewater, 300 kg of sodium chloride per day, and that can be used to buy any industry, any softener plant that can be used. Even they can stop, they have also a softener, so they will stop their buying of sodium chloride or vacuum salt for softener regeneration. So this is the just real life example I shared with you with respect to resource recovery. And after recovery, residual materials, if it is there, because I am sharing this is the sodium chloride, but other industry, this after resource recovery, it may contain some other contaminants also generated. So after recovery, residual, if contaminants are there, if it is hazardous, that's why characterization is most important. Residual matters, then you have to go for a treated and dispose as per the common rules, captive facility or in a common TSDF. TSDF means full word, transport, storage, disposal facility. So after recovery, okay. So why we need to care for the hazardous waste? These are the scenario already, though the rules come up, but it is a very few, even it is continuing. You can see illegal dumping, ETP failure of the effluent treatment plant due to the poor operation maintenance. Then throughout the India, it is a issue of the RO reject. RO reject, I am in the industry. So from the industry forum, now it is a jointly associated with the various academic and research also with respect to the technology development, collaborative research. We are also doing various ceramic institute, other research institute also. So RO reject, you know that all over India, RO reject is a big issue. RO reject contain high TDS and it also generate lot of waste. So RO reject is even in the ETP after recycling, the reject is discharging. So RO reject handling is a big issue. So rejection of RO, illegal dumping, ETP failure, RO reject, it can be minimized by a, that is a challenge, minimized by RO reject can be further minimized by proper handling or optimization of the water resources. That can be, and also the RO reject, if we go for a suitable evaporator, the crystallizer, that from there is a possibility of resource recovery. But see, for that work has to be done. How many RO rejects had been, you can, that is a great opportunity, because many industry are rejecting RO, but nobody is looking after the rejection, RO reject, what is the resource in the reject? Is there any resource now, or it is a hazardous waste? That then accordingly it has to be handled. So that's why the rule for, we need to care for that also. And not only that, if we illegal dumping, it will be failure, RO reject is there, it will contaminate the groundwater, which is our one of the major source of drinking water. And not only drinking water, you know, India being an agriculture-rich country, 85% of the groundwater extraction. India, if you see the water consumption pattern, in India, the total water consumption, groundwater consumption, whatever extraction is done, more than 85% of the groundwater is used for agriculture purpose. Agriculture and vegetation, various vegetation, crops cultivation. So agriculture consumes more than 85% of the water, groundwater. And if you continue this type of activity, what I am sharing in this picture, our groundwater is severely contaminated. And it is happening now. In groundwater, we are getting a lot of various types of toxic elements, then nitrate type of disease-causing organism. Then a lot of time we get the pathogenic bacteria also, groundwater. It is very common now. So its effects and the agriculture, vegetation, and also the aquaculture. So if ultimately goes to a stream or the ecosystem, it enters the aquaculture, aquatic life may disturb. And many incidents in India, it was sometimes not hidden in the news, but a lot of time it came up in the news that the lot of fishes 2 years back in some of the areas of the Chennai, one pharma industry, it has came in the news also, not in the newspaper, but in the reported some scientific journal. So some huge amount of fish was become dead. Fishermen's, their fish cultivation, the fishermen are in threat. Their livelihood in threat. That company managing director has been caught, and he has to report to the High Court Justice, Chief Justice of High Court, and huge amount of money has been penalized. So these are some real type of experience. It is already occurring. So that's why you understand why the need for care for the hazardous waste. So hazardous waste management. See, the green part is it is the most environment, most preferred option. It may be hazardous waste management can be carried out by landfill and incineration, or it may be seed disposal. But seed disposal is nowadays, most of the cases, it is not practiced. It is there, one of the process, but it is no longer is in practice. Very rare case, depending very specific case. If, as I'm telling, some salt materials be there, but salts are there, magnesium, calcium, various types of, because sea is rich in mineral content. So if it is contain the toxic element, then it will consume, affect the sea and sea animals or sea animal creatures. So sea disposal is but before sea disposal, you have to characterize it. If you see that the waste, hazardous waste contains only the mineral, various types of minerals contents are there, then you can safely that you can decide. Then landfill incineration is there, but there is some landfilling rules are there. I will share in the later part of my presentation. Landfill and incineration, what the landfill and how to landfill and what is the incineration part. Then pre-processing before the disposal. Pre-processing, that's why pre-processing sometimes helps the hazardous waste management very effectively. Then co-processing. Sometimes many hazardous waste nowadays is co-processing with the like fly ash. Similarly, other hazardous waste, lot of hazardous waste it is now co-processing in the cement industry. Okay, so co-processing, pre-processing, co-processing, and plasma technology. Plasma technology, it is based on some thermal based technology, thermal applications, which create lot of destruction of the hazardous toxic components. So plasma technology, pre-processing, co-processing, some of the parts of the hazardous waste management. So now let us see what are the possible sources in an industry. Possible sources. If you see the entire diagram I have shared here will help you to understand that what are the possible sources of hazardous and other waste in a facility, industrial facility. If our input materials in an industry, suppose raw materials are there, chemicals are there, it may be additives are there, then water, energy, etc. These are the input materials. Then input materials we are giving to a production process. So production process, so once the production completed, we have got the desired product. And sometimes we got some byproducts also. Desired product and byproduct. And what are the generations? Some process residues are generated, which may be liquid and solid waste, or it may be hazardous and non-hazardous waste. So process residues may be two types. One is the liquid and solid waste. It may be hazardous, non-hazardous. Then from the production process, two parts are there. One is the liquid, the wastewater going to ETP. From ETP also, on ETP, there is two types of sludge generally generated in a ETP. One is from biological treatment, biological sludge, that is regarded as a less hazardous and sometimes non-hazardous as well. But from ETP, the primary treatment, where a lot of chemicals are used to remove the suspended materials or oily waste material, that belongs to the hazardous category. Suppose in the ETP primary treatment, ETP actually three types of treatment: primary, secondary, or sometimes called biological, or sometimes tertiary treatment. So in a effluent treatment plan, primary treatment generates mostly the hazardous sludge in a ETP is generated from the primary treatment. One is the chemical used like alum, lime, various chemical as a coagulant, or reaction mechanism also involve lot of breaking of the chain. Sometimes in the primary treatment, deactivation is required. Where, so that's why in the primary sedimentation clarification process, hazardous waste are generated. And also if it is a oily waste, suppose edible oil industry, refinery petrochemicals can generate the hazardous waste. Rolling oil emulsion, in a steel plant, there is a cold rolling mill, hot rolling mills are there. Rolling oil emulsion may generate hazardous waste. But the biological sludge generally not considered as a hazardous. It is most of the cases considered belongs to the non-hazardous category. So biological sludge, you can minimize that. It will give you the opportunity to recycle the biological part of the sludge. And the hazardous sludge, you need a strong characterization. Then only you can go for the decision. And apart, this is the one part of the ETP I have shared. And in the production process, another part is the air pollution control, because the air pollution also may occur. So air pollution control device and systems also, the device collected lot of residues. So after collection of the residues, that it has to be collected and storage in a particular area, so that the residues coming from the APCD, that means air pollution control device, is in short called APCD, mostly they are also hazardous in nature, because air pollution control, lot of suspended impurities, the toxic chemicals may be there, it may be VOCs, volatile organic carbons may be there. So they are most of the cases, they are mostly hazardous in nature. So these are the various categories of the sources of the hazardous waste. So hazardous waste management basic needs to prevent the following. What are the basic needs? Basic needs to prevent the following. The hazardous waste management is the basic requirement. So why basic requirement? If we have to prevent the following, the management of hazardous waste is utmost essential. So otherwise, these are the things may happen. Fire and explosion in the landfills, because you don't know the where, well, many solvents, many hazardous chemicals may be there. We may react together, may lead to the fire, and explosion may occur. Then release of toxic chemicals from landfills, resulting in environmental pollution. Toxic chemicals, various types of toxic chemicals may be there. It may be metallic components, it may be non-metallic components, like cyanide, phenolic compounds. So various types of. So, and also there is a, from the R&D is also very much important. Okay, so then export of hazardous waste from developed to developing nations like Africa, Asia, etc. Developing nation. So export of hazardous waste from developed. So these also create also lot of problem. If you do the proper management, this can be minimized, because the developed to developing country, the developing nations like India, so developed to developing nations like, and also India and Africa and Asia's countries. And then intervention, if we do the proper management, then intervention of international body like United Nations can be minimized. Otherwise, if it is goes to such a great extent, then sometimes it may happen that United Nations Environmental Protection or UNEP may taken into consideration. Intervention may occur. Then this is the very important. I will discuss the why the Basel Convention, the establishment of the Basel Convention to set the guidelines of international and transboundary movement of the hazardous waste. Very important with respect to hazardous waste management. And most of the developed and developing nations are the member of the Basel Convention. Okay, so so this is the hazardous basic needs to prevent the following. Then how hazardous waste rules are important in an industry sector. How hazardous importance, what are the importance of the rules? So rules provide, helps the industry to control on the generation, collection, treatment, import, storage, and disposal. So all these stepwise, all these area can helps to control by the industry for management of the hazardous waste. It provides guidelines for handling, storage, utilization, and disposal. Provide guidelines. The one is the how to control it, and also the provide guidelines. And waste not permitted to be imported for dumping and disposal in the country. This is extremely, highly restricted, strongly restricted now. And regulate imports of waste for processing and use for recovery of resources. And sometimes some waste can be imported, okay, for processing, or as I am telling, the resource recovery. But there should be some regulation. It has to be some regulatory, but you would, so that the mismanagement will not occur. So for processing and use of the recovery of the resource. So that is also regulation of this import of the waste. Sometimes, as I'm telling, that the co-processing may occur, pre-processing may occur, but for that, there should be some regulation need to be there. So hazardous waste generation in the country, though, let us see what is the hazardous waste type of typical hazardous waste generation picture. As per the latest CPCB estimates, about 7.2 million tons per annum of the hazardous waste is generated in the country from about 60,000 industries. About 3.39 metric ton per annum are out of this, about 44.3%. Okay, 44.3% are landfillable out of this. So CPCB has conducted these estimates that around whatever the hazardous waste generated, out of this 44.3% are landfillable, 47.25% are recyclable, and remaining 8.5% is incinerable waste. So this is the waste generation and some studies and estimates carried out by the Central Pollution Control Board. And about 83% of the total hazardous waste. Now see what are the major states of the 7, it is generated 83% of the hazardous waste is generated from the 7 states. Visualize: Gujarat, Maharashtra, Tamil Nadu, Andhra Pradesh, West Bengal, and Chhattisgarh. So these are the 7 states which contribute to 83% of the total hazardous waste. 83% of the total hazardous waste. Okay, so this is contributed by the 7 states. And what are the facilities? About 29 common secured landfill facilities are there in 16 states. And 14 common incinerators in more than 7 states. So in 16 states, around 29 common secured landfill facilities are there, and 14 common incinerators in more than 7 states are there. So this is the hazardous waste generation, one estimates carried out by Central Pollution Control Board under MOEF, which give you some idea of the generation. And now let us see the general characteristics. What are the general characteristics of the hazardous waste? So hazardous waste is mostly generated. Now after that, we'll see what is the rule state, what are the components of the hazardous waste, which waste we'll call the hazardous waste. This will discuss we discuss about the rules. That will came to know what are the waste we call this hazardous waste, which are included in the hazardous waste and which are not included. That is also applied in the new rules 2016 that we will share. See the hazardous waste characteristics and the potential hazards on living species and the environment. So it will explain the characteristics of the hazardous waste with respect to its hazardous nature and corresponding effect on the environment. Suppose one type of hazardous waste may be there which are flammable, or explosives type. So like petrochemical industry may generate the hazardous waste, which are mostly the flammable in nature. Solvent extraction plant, the petrochemical industry, refinery petrochemicals. Then explosive like in Indian Explosive Limited, various explosive producing company may be there. So that may produce the hazardous waste also. Nitrate based explosive are there. Some of the plants one organization, they have around 3-4 plants are there. They are producing some explosive detonator, or that's hilly place, the charging of the in the hilly area, road construction purpose that is used. For that, after generation, it may generate hazardous waste. Okay, so this type of waste may cause fire and damage to the surroundings by producing harmful gases. So these are the impact, and some are oxidizing in nature. So this type of waste may yield oxygen and thereby cause or contribute to the combustion of the material. So combustion may occur if the waste is oxidizing in character. So after time, it may combustion. It may found that the combustion is occurring, and you can see after time, you can see the smoke is we often we see during the traveling also. So many waste dumping waste, we can see that some fumes are occurring. Sometimes from fumes, ultimately, its flames are also coming. If it is oxidizing, this may, apart from flammable and explosive type, then it may be poisonous also. Poisonous also. These waste have high potential to cause, because poisonous is acute. It is the most dangerous. These waste have high potential to cause death, serious injury, or to harm health or by skin contact. So this is the flammable, explosive, oxidizing, poisonous. Let us see what are the other characteristics are possible with respect to hazardous waste. It may be infectious. We call it poisonous. Then it may be infectious also. So hazardous waste containing microorganisms. So when it is infectious, see, the poisonous may be due to the presence of toxic chemicals may be there. Okay, so due to toxic chemical, most of the cases it cause the poisonousness or injury to health or skin contact also. Now, if it is a infectious substance, it is mostly due to the microorganism, which is arises due to the microorganism, harmful microorganism present, and which may sometimes it is very difficult to understand the health effect. Sometimes, see, this is the hazardous waste contain microorganism and toxin responsible for disease in human and animals. And see, that's why often we see that the even doctor also sometimes the unable to diagnose a particular patient which is suffering from a infectious substances. And see the people who are handling these hazardous waste. Think about those people who is being directly exposed to this hazardous waste. If it is infectious, say he may form a disease, he got admitted to the hospital. Even lot of experiment, X-ray, lot of colonoscopy, entire body scanning is done. But doctor is understanding that some infection is there. But what is the diagnosis? It is very difficult, unknown, and ultimately it may to death. So various types of fevers. Nowadays, often, the doctor unable to organize the road. Apart from corona, today's corona is there. But that is different. This is also a microorganism. Similarly, various types of fevers are a lot of sometimes in our known periphery also. Somebody is no doctor unable to diagnose the exact cause of fever. Infection, some infection are there. What is the real expansion? So this is a very dangerous effect of the hazard. This is nothing but our pollution. Then it may be the corrosive also there. These wastes are chemically active and may cause severe damage to the flora and fauna if it is a corrosive. And not only flora and fauna, This, if it is a hazardous waste which is corrosive in nature, suppose during the rainfall, if it is a leached, goes to the soil. If it is a waste containing, say, corrosive material, if it is a corrosive in nature, to understand what will happen to the soil structure and agriculture and other entire soil. So entire soil will get damaged in that area. Even the waste, suppose waste are taken out, the dumping site change from that particular place to other place. But due to the leaching and corrosivity, the entire soil become ineffective. It is not below, again, it is not at all fertile if it is a corrosive type of there. So, and not only the water going to the flora and fauna nearby the soil, if it is goes to the leaching and nearby flora and fauna, it may severe effect to the ecosystem. It may disturb the natural dynamic equilibrium of the ecosystem. Then ecotoxic. This waste may present toxic effects and adverse effect to the environment, which I have already shared with you, that the natural dynamic equilibrium of the ecosystem. So it is ecotoxic. Then toxic, delayed or chronic, slow effect. This waste, if inhaled, ingested or penetrate to the skin, may cause delayed or chronic effect. Sometimes when they expose, initially it is unable to understand. After few days past, you can, the effects is unable to, initially it is not possible to understand or feel the effects, but after few days it is possible to understand. This is called delayed effects. So, or chronic effects. So these are the various characteristics I have explained, the various types of hazardous waste, which is almost all categories, starting from infectious, corrosive, ecotoxic, toxic, delayed or chronic, and also the poisonous, oxidizing, and flammable and explosive. So as per rules, these are all included of the general characteristics and their effect on the environment. Now, some of the types of waste and their what type of disposal may be there. This I am just sharing, that depending on the industry and other sources. So what is the possible disposal may be there. Suppose if it is just a spent organic solvents from bulk drugs company, spent organic solvent from bulk drugs, it has to be disposal, maybe the incineration. But for incineration, you have to follow the hazardous waste rule guidelines are there. There is some rules are there. There is some for incineration, there is some specification for the incinerator. In the last part, I will share some of the incineration, what is the height of the incinerator, what are the, depending on the solvent, design aspects are there. Then OS specification product. Okay, OS specification products means, suppose a product is produced. After production, once the product is produced, is going to in a standard practice, going to a quality control lab for testing as per the specification, QC lab. So after analysis, the QC quality control reject the product. That is called OS specification. Why rejection? It is due to the product is not as per the spec, failed to meet the specification. Production has been done, but the product failed to meet the specification. This is called OS specification. This is declared by the quality control department of the industry. And this also generally goes for incineration. Then process waste, residues from the paint manufacturing also generally goes for incineration. So these are the waste. You can see they are mostly the organic type of material. They go for the incineration. And now process waste from dye, intermediates containing toxic metals. So see this waste, all these pharma waste, organic solvents, or specification product, process waste from the paint manufacturing industry, generally disposal practice follows the incineration. And process waste from dye intermediates containing toxic metals generally go for stabilization and landfilling. Stabilization and landfilling. And then the ETP sludge. ETP sludge, I have shared the possible sources of the ETP sludge, generally to transport, storage, disposal facility for landfilling. And used oil sold to CPCB registered recycler. So used oil, some oil is used. Some oil is used. After that, it has been rejected in the process or various application in the lubricating purpose, various workshop machinery. It has been used. After that, the waste oil is generally CPCB. There is some companies are there who will again take the used oil. CPCB, there is a registered recycler are there. You can sold to them. So that way you can manage the waste oil management as a hazardous waste. It has to be sold to, but you cannot sold to, remember, you cannot sold to any other authority. So that authority where you are going to sold must be, they are enlisted in the MOEF, under MOEF or Pollution Control Board of the Central as a registered recycler. Okay. Then discarded containers, barrels, liners. Okay. So they discarded, they generally have to go for decontamination, detoxification, and sold to, it is GPCB or CPCB. It is suppose it is first applied in the, because you know that the Gujarat is very good management. So Gujarat Pollution Control Board approves CAP processor. So in India, you can see in Gujarat, lot of many, I think in the Gujarat first solid waste management side, the recycling first plant word is Gujarat. Okay, so discarded containers, barrels, liners. So after decontamination, detoxification, sold to GPCB approves CAP processor. Then process waste, residues may go for the incineration. Spent ion exchange resin, spent resin containing toxic metals, because many power plant like Sopna, DM plant, lot of resins are there, used resin. So they must go for stabilization followed by landfilling. You have to go for the MSDS of the resin, material safety data sheet. The company who is supply, you have to go for them. In there, it is clearly mentioned the stabilization procedure, and then landfilling as for or incineration depending on the nature or characteristics of the resin. So date expired or specification, already we have explained, it is go for incineration. And incinerated as, and after incineration, there is some as generated. So that as is again go to TSDF. That is the transport, storage, disposal facility for landfilling. Now, incinerated as, while by saying that to TSDF for landfilling, just I am sharing one thing. Nowadays, you know that the briquette is used in many boiler. In an industry, boiler is used for the steam generation purpose. Now, in boiler, small and medium scale boiler, generally fossil fuel is used. What are the fossil fuel? Either diesel, HHD, okay, or coal is used. Now, all these two are considered as a not at all a green fuel. They are the polluting fuel. You know that the once we burning the coal, what are the emission may occur? It's sulfur, SOx, NOx, carbon emission, SOx, NOx. Also the ash generated from the HHD or coal may contain toxic metal also, toxic element. The sludge is highly hazardous. So that's why nowadays new technology has been developed in the briquette. Briquette is which is generated from the waste residue of the various tree leaves, sawdust, various waste material. Biomass, it is called biomass briquette. Biomass briquette, which is now is very much promoting as a green fuel, as a renewable energy source, replacing fossil fuel like coal, and fossil HHD. Okay, so these two are replaced by the biomass brigade. While burning the biomass, some ash is generated in the boiler. Okay, and the incinerated ash, generally you have to go for THDA for landfilling. But the advantage of the biomass brigade, the ash generated in the biomass brigade do not contain any toxic metal because it is a green fuel. It contains only carbon. Ash contain very limited percentage of silica may be there, and it is considered as a very less quantity ash, and it does not contain any toxic metal. So, but if incinerated ash generated from a HHD or coal, it is contain toxic metal. So for landfilling purpose, green fuel is the much more better option. Nowadays, many industry as a waste minimization practices, the generation of waste will be minimized if we use the biomass brigade, and also the emission, because biomass brigade does not contain any sulfur and nitrogen. So in the emission part, so dual facility in the emission part, you can minimize the sulfur nitrogen. One can go for carbon credit also once you use the biomass brigade. And lot of industry, I have deeply associated with the various Sikkim zone, lot of pharma industries. So all the Sikkim government, the pollution control board is very strong. So they are now gradually, all the industries are gradually moving from coal and HHD to brigade fire. And Sikkim, since it is an organic state, the biomass brigade generated the ash it is considered as the totally non-hazardous, and it is easy for landfilling and not at all required for co-processing also. So this is now gradually, so this is the way that the hazardous waste can be minimized. This is the another live examples where that is a huge opportunity to source minimization, and also the exploration of the new technology as a green fuel. Not only the solid waste, also this will help you the emission reduction and leading to carbon credit also. Okay, so hazardous waste, now just the hazardous materials and substances from the metal production on processing. In a metal processing plant, these are the possible waste may be generated: sludge from the cooking tanks, material that is contaminated with the cutting fluid or oil. It may be the oily waste emulsion, greasy material may be there in a metal processing, any metal processing industry. Acid and alkali-based solutions may be there. These are the possible sources of hazardous materials from a metal processing industries. Solvent used for degreasing scrap and cleaning boilers. Okay, so sand from casting process that is contaminated with metals or chemicals. So this is the sandblasting or casting process. The hazardous waste may be generated. Then pollution containing equipment that has been used on spills of hazardous material. Okay, so spillage of the hazardous material. Then these also become hazardous because these contain analysis, computer monitors, fluorescent tubes. These are also the other parts of the hazardous waste. This is with respect to the these last two, maybe not only the metal processing, but any industry can generate this one. Now comes to the legal requirements. What I am discuss about the legal requirements. Okay, so this we have explained the various characteristics of the hazardous waste, the hazardous waste scenario, and what is the possible disposal we have discussed, and the characteristics of the waste, the generation of the waste we have discussed. Now comes to the what is the legal requirements. So Ministry of Environment and Forest, Government of India notified the hazardous waste rules on July 28, 1989. Okay, under the provisions of the Environment Protection Act 1986, which was further amended in the year 2000 and 2003. Okay, so these legal aspects are there. So any industry have to follow these legal aspects. Then the hazardous waste rules 2008 were notified for effective management of hazardous waste, which do not come under the purview of the Prevention and Control of Pollution Act 1974, Water Act, and the Air Act, which do not come under the purview of the Water and Air Act. So see, this is a separate rules again from in the 2008. So in this way, and lastly, the final hazardous waste management rule 2016 published in the Gazette of India, Extraordinary Part 2, Section 3, Subsection 1, Government of India, Ministry of MOEF, Forest and Climate Change, New Delhi on 4th April 2016. This is the last amendment means on the hazardous waste management rules. Now, the hazardous waste generated in the establishment shall be sent to or sold to a recycler or reprocessor or reuser registered or authorized under this rule and shall be disposed of in an authorized disposal facility. Like in our country, in most of the country, major, there should be, you have to dispose the, as per the rules, following the rules to a authorized body. Like one company called Ramki. Ramki, suppose in a industry in this, in our region, even not only the eastern part of India, or throughout the many, Ramki is the most authorized agent for the handling of the hazardous waste. And they are following the standard rules. You have to be a member of that, of the body of the waste taker, who is the Ramki. Ramki is the recommended by the Pollution Control Board. So you have to be a member and they will charge you per ton of hazardous waste. So here, that's why your investment to the hazardous waste management will be increased once you generate the more sludge or more hazardous waste. That's why to minimize the cost of the hazardous waste management industry, that's why these approaches are come up. The better management, waste minimization practices, then resource recovery, recycling of the waste. So once you recycling the waste, when you recover the waste, when you minimize the waste, your disposal cost will be minimized. At the same time, you can save the better for the environment. So the hazardous waste transported from an establishment to a recycler or recycling or reuse or reprocessing or to an authorized facility for disposal shall be transported in accordance with the provision of this rule. The high volume, low effect waste such as fly ash, high volume, low effect, like fly ash. High volume, low effect means in a power plant, you know that the how much amount of fly ash is generated, but it has a compared to the other hazardous waste, like in a chemical processing industry, petrochemical industry, the waste generated is much hazardous than the fly ash. It is, that's why it is called high volume, but their quantity is not so high, which is in case of fly ash. Then phosphor, gypsum, red mud. Phosphor, gypsum generally in a fertilizer industry, phosphate-based fertilizer. Okay, so this way you can, if you see to the, you can see that if you visited the Paradip, if you once anybody visited the Paradip, you can see that there is a industry, two industries there. One is the IFCO. Now initially Oswald fertilizer, two fertilizer plants are there. One is Paradip phosphate. You can see the gypsum bed. The after gypsum, that is the solid waste generated. Okay, so then red mud. Red mud is generated generally from the alumina industry, bauxite to alumina, this red mud. Then slag from the pyrometallurgical operation, mine tailings, chromium mines, coal mines, lot of tailings are there. Tailing means after the processing, the tailing pond is there. The waste through a slurry, it kept in a pond-like area. That is called tailings. And ore beneficiation results. After the ore recovery of the ore, It may be applied to any mining application. Recovery of the ore. It may be chromium ore, it may be iron ore, it may be aluminum ore or zinc, maybe. So ore may mostly applicable to metallurgical industry. Rejects are excluded from the category of the hazardous waste. So actually, these are generally these are not included in the hazardous waste as per the legal. They have because of they are not like the chemical and other toxic components. Like gypsum contain calcium. Fly ash contain metals are there, but the cadmium, lead, it's not so high like a chemical waste or hazardous waste. Okay, like chromium 6, tannery industry slag, chromium 6, that is a highly hazardous. So it is excluded from the category of the hazardous waste. Handling and management of hazardous waste during the ship dismantling, such as used oil, waste oil, damaged asbestos containing material, paint chips, used chemical are also excluded. Actually, these comes into the separate waste management rules. So in terms of hazardous waste rules, now let us see which waste we call the hazardous waste. Section 3, rules 3, section 1. Rule 3, section 1 means any waste that has physical, chemical, reactive, toxic, flammable, explosive or corrosive characteristics and is likely to cause danger to the health or environment, whether alone or when in contact with other wastes or substances, and that include the waste having constituents specified in Schedule 2. So Schedule 2, there is a Schedule 2 in the hazardous waste management rules. So which Schedule 2, there is some specification up there which will give you the idea of what are the waste. Actually, it is a lot of biomedical waste. There is a separate rules come up as a biomedical waste management. Okay, so there is a lot of diversification and lot of classifications are there. Since the time is short, so that's why we cannot explain, but it is available. You can go through the hazardous waste management rule. Once you go to, you can have just to give you an idea, in Schedule 2, you can have a total constituents specified in the Schedule 2. In the rules is available, you can directly download it from the website and you can see in the Schedule 2 part, it is there. The concentration of the compounds were equal to or more than the limit is indicated, it said in the schedule. Where equal to or more than is the limit. What is the limit and what is the concentration of the various compound? It also maintained in the schedule. This schedule includes number of compounds from metal processing industries comes under provision of hazardous waste rules. So now comes the Basel Convention. So Basel Convention is already, I have shared, the control of transboundary movements of the hazardous waste and their disposal, usually known as the Basel Convention. It is an international treaty that was designed to reduce the movements of the hazardous waste between nations and specifically to prevent transfer of hazardous waste from developed to less developed nations. So otherwise what happens, see, most of the countries are exporting or importing. The developed countries generally try to dispose as a scrap to the developing nations. So that's why this international treaty has been signed under the Basel Convention. The convention was opened for signature on 22nd March 1999 and entered into force on 5th May 1992. The waste specified in Part A or Part B of the Schedule 3 of Hazardous Waste Rule is respect to import and export of such waste are dealt as per the annexure. This I am not annexure 6, 7 and annexure 9 of the Basel Convention. So these are just for your awareness. So as a party to the convention, India is also a member. So India is obliged to regulate and minimize the import of hazardous waste. See, the Basel Convention mostly related to the import-export or transboundary movement, inter-country, in one country to another country, international treaty. So India is obliged and regulate to minimize the import of hazardous waste or other waste for disposal or recycling. Because nowadays many plants are there. We are recycling and producing lot of good products. So some of the industry, other country, they are producing lot of raw materials, maybe they are, which are now recycling. So various plastics are now converted to useful products, which is highly hazardous. Plastic bottles. There is a plant in our area in the nearby Kolkata where they are using the waste plastic bottle and they are converted to synthetic cotton. That is a plant is there. They finally crush the material, make the granules, and it is through the conveyor belt. The granules are to the elevated structure. They are keeping to the high voltage, high elevated position. Then through the various thermal expression, that is maybe all the plasma technology, you can say, the elongated. All the granules are elongated. And ultimately, they are producing, see the plastic bottle to they are producing synthetic cotton. Synthetic cotton is producing. Their production, when they started the plant was only 18 metric ton per annum, per day, 18 TPD plant. Now it is more than 45 TPD plant. It is nearby Calcutta. And they are giving lot of subsidy by the government of India because they are using all the waste plastic material. And you see that you can see the pillow is available in the market. Various types of pillow are with a synthetic cotton. Reliance is producing. Lot of other companies are there. Reliance is one of them. Is synthetic cotton. That is nothing but made from the waste plastic bottle. Remember, plastic bottle first bring to the plant, washed with various water, the hydrojetting, and the waste water goes to the effluent treatment plant. After that, that bottle over crushed in a machine. It is a fully automated and converted to a fine granules in a specific shape of granules are there. And then granules again the polished and through the conveyor belt. This is the process. Conveyor belt goes to the total high altitude zone and accordingly thermally evacuated and converted to synthetic cotton. Yes, any question, anybody? I think somebody's anything. Okay, so any metal processing or recycling. So this I am too going to. So this is the hazardous waste management rules 2016. So applications, these rules will apply to the management of the hazardous and other waste as specified in the schedules to these rules, but shall not apply to. See, the 2016 rule is not applicable to the wastewater or exhaust gases as covered under the provision of the Water Act and Air Act, and the rules made thereunder as amended from time to time. So water and wastewater and the air pollution emission is not included in the hazardous waste management rule. Waste arising out of the operation from ships, okay, beyond 5 kilometers of the relevant baseline as covered under the provision. This is, as I am telling, this is a separate act, Merchant Shipping Act, 1958. And the rules, so these are not included in the hazardous waste management rule. Similarly, radioactive waste. You may say that radioactive waste is also hazardous, but for that there is a separate act out there, Atomic Energy Act 1962. So these are hazardous, but they are under the different act. These are not included in the hazardous waste act. Then biomedical waste, okay. Then including the municipal solid waste. Till now, anybody may think that what about municipal solid waste? Because municipal solid waste also generated a lot of hazardous waste. Some recovery is there, composting may be there, but other parts, lot of hazardous there. So it is under the separate rules. You can see the municipal solid waste rules 2000 made under the act and as amended from time to time. So these radioactive waste, biomedical waste, waste cover on the municipal waste, shipping act, water, wastewater, air, these are enacted in a separate act. So these are not included in the hazardous waste management rule. Okay, so this is just for your information and knowledge and having an idea what is the what actually following in the hazardous waste. So storage of hazardous waste. The occupiers, recyclers, reprocessor. Hello. So occupiers, recycler, reprocessor, reuser, and operators of facilities may store the hazardous waste for a period not exceeding 90 days. See in a storage, how much storage, that is also included in the guideline, not more than 90 days, and shall maintain a record of sale, transport, storage, and proper documentation should be there. In a plant, that means in a plant you cannot store for the more than 90 days as per the rules. Okay, and you have to keep a record of the sales, transport, storage, and recycling. How much, if you are recycling, go for recycling, reprocessing, every stage you have to record it. Okay, State Pollution Control Board may extend the said period in these 90 days in the following cases, such as if it is a small generators up to 10 tons per annum. If the industry is generating all up to 10 tons, the storage may be extended to more than 90 days. Recycler, reprocessor, and facility operates up to 6 months of their annual capacity. Okay, so if reprocessor facility operators up to 6 months of their annual, in that case, storage, so they run for the recycling plant more than 6 months, up to 6 months. Then it can be extended for more than 90 days. Then generators who do not have access to any treatment, storage, disposal facility in the concerned state. Suppose in a state, suppose in a Jharkhand or in a Bihar, their state don't have any facility to take that sludge or storage facility. Like then it can be stored for more than 90 days. Like I am just telling you, in Sikkim is a lot of pharma industry there. I have told about the Sikkim is a green state, that is okay. But whatever storage is there, a generator is generation is there, Sikkim don't have any storage facility. They have to use the storage facility of the Central State Pollution Control Board under the West Bengal Pollution. West Bengal Pollution Control Board has a 3 facility. One is Siliguri, one is Haldia, and Durgapur. Okay, so Sikkim don't have any facility. So in that case, they may go for more than 90 days. Just to share you the example, real example. Because they have to take the facility of the West Bengal. Their disposal maybe within more than 90 days may be allowed. But they have to take the consent in written from the State Pollution Control Board. The waste which need to be specifically stored for development of a process or its recycling or reuse. Or sometimes the waste has a value. They are planning to recycling it and specifically stored for the development process. Suppose some research is going on. They are doing some inbuilt research for recycling purpose, reuse purpose. In that case, but everything has to be declared to the State Pollution Control Board and has to take consent from the Pollution Control Board. Okay. So then transportation of the hazardous waste. The transport of hazardous waste should be in accordance with the rules by the central government under the Motor Vehicle Acts, because transport comes under the Motor Vehicle Acts and other guidelines. The processor shall provide the transporter with the relevant information regarding the nature of the hazardous waste as per there is a Form 11 is available, and measure to be taken in case of emergency, and shall mark the hazardous waste container at Form 12 as Form in the 12. So in case of transport of hazardous waste to a final disposal facility for treatment, storage, and disposal existing in a state or other than the state where the hazardous waste is generated, the processor shall obtain no objection certificate from the State Pollution Control Board of the both state, which I have already explained. Now, so during transportation and storage, various types of forms are used. Okay, these are the forms with a color code. This is the practice actually followed by the industry. So there is this type of white, yellow, pink, orange, green, blue. So how many color? 1, 2, 3, 4, 5, 6. So during the manifest movement document to be used within the country and within the country. So suppose during the transportation and storage, these forms has to be applied, and it is clearly written the which color form has to be kept well for record purpose. Like white form to be forwarded by the processor to the State Pollution Control Board committee. White form. Yellow form to be carried by the processor after taking, who is going to take the form sludge for the processing purpose. Then pink form to be retained by the operator of the facility. The operator inside the facility after the signature. And orange form to be returned to the transporter. Orange form to be returned to the transporter by the operator of the facility. So these are the ways, the various form recording purpose. As per rules, these are the various colors are generated, various colors of form. That is a manifest system movement document for record purpose. So to be retained by the operator of the facility to State Pollution Control Board committee after treatment and disposal of the green form, and blue to be returned by the operator of the facility to the processor after treatment disposal of the hazardous waste. So these are the manifest various color code with respect to the handling, and what are the different code and their application, what to keep it for during the movement of the hazardous waste. And now see the more criteria for disposal of the hazardous waste. So criteria, if it is a biodegradable, organic, suppose characterization I have told is very important. Biodegradable organics less than 5% and non-biodegradable less than 20%. Calorific value less than 2500. So it is declared as a no toxic, non-biodegradable less than 20. So direct landfill. So this type of waste as per the rules can be go for direct landfill. And landfill after stabilization, if the biodegradable part is less than 5, then non-biodegradable organics also less than 5, less than 20%. But calorific value is also less than same. That means it is the same criteria with but it contains some toxic metals. So what happens in that case? You need to stabilize the toxic metal with some chelation or chemical reaction. Some process has to be pre-processed, as I have told you in the first part, hazardous waste management. So here you understand where pre-processing is required. So this is the after pre-processing stabilization, you can go for landfill. And if does not contain any toxic metal, it can be go for direct landfill. And where is the incineration is possible? If biodegradable part is greater than 5%, that means it contains more of organics. Non-biodegradable organics also, that means greater than 20. That means both organic content is very high. As I am telling in the initial disposal, like paint industry, pharma industry, spent lime, lot of resin, and calorific value also very high. So they can go for a dual chamber incineration. So these are the disposal pathways based on the characterization of the hazardous waste. So hazardous waste during the characterization, very good laboratory you need to characterize for a required. These are the some equipmental facility. You can see the gas chromatography, mass spectrometer is useful because to entire quantitative the analysis of the various organic toxic components, then atomic absorption spectrophotometer, as I'm telling, for toxic metal analysis, elemental analysis like carbon, hydrogen, nitrogen analyzer. These are the some instruments and facility, state-of-art laboratory which contain this type of analytical instruments for characterization. Because only after characterization you can follow the guidelines and what to be do, either landfill or disposal pathways. So analysis requirement, these are the analysis requirement. This is also as per US EPA. Physical, color, texture, calorific value, LOD, loss of drying, loss of ignition, then pH, these are the cyanide, sulfide, inorganic total, the identification of organics. So these are the, in case of corrosive, flammable, toxic, and reactive. So these are the some art of laboratory and analytical part. And now I am showing some of the real life images of the some images. You can see, these are the images of the facility that there is will be no leaching. So these are the facility has to be built up: transport, storage, disposal, and storage phase. These are the, it is for transportation purpose. It is a real life picture. You can see this is the going on hazardous waste. You can see. So these are the soil layers spreading and compaction of the waste, and vent, and sometimes some gases are, that's why this type of vents also made, and site covered during the monsoon, so that during the monsoon you can see that the site is covered during the monsoon period. This type of coverage has to be, so a lot of management aspects are there. And you can see the temporary storage shed also sometimes has to be built. Okay, and this is also a temporary storage area shed, so that there is no washing and spillage during the monsoon period is occur. And wave bridge also there, to calculate the amount of how much, as I am telling you, this in the document movement, when the manifestation system, it is required, wave bridge and sampling. And these are the some incinerator examples, pictures of the incinerator. And hazardous waste incinerator chimney, you can see the stack height 35 meter. So emission norms for the common incinerator: CO should be maximum 100, NOx maximum 400, SOx 200, and total TPM, total particulate matter, maximum 50. So these are the acidic part, dioxin, furan only 0.1, and total organic carbon maximum 20 milligram. Okay, so these are the some norms, emission norms of the common incinerator, and height of the chimney is around, should be 35 meter. And this is also some multi-effect evaporator plant, which is also the, from the high solid content extraction is required. And you can see this is another picture. And sometimes of the storage has been fulfilled. This is also, you can see lot of area. You can in Jamshedpur area, you can see the Tata Steel near, which was initially a slag based. Now it is converted to a green park. This, it is like this is in, if you see the anybody, I don't know, visited the Tata Steel after Jamshedpur, there is a huge hilly area is there, filled with slag of that steel plant slag. Now it is covered with a green park. So after the completion part, the filling is done, it can be converted to this type of facilities also. Grass cover with our landfill. Okay, vegetable cover, various types of vegetable, the grass, this type of coverage is also possible. This should be a very good practice, innovative approach of the hazardous waste management. So 10 and thousands of compounds are known to be hazardous. At present date of testing, it would be take centuries to assess their long-range synergistic effect, because total analysis, that's why the proper management should be, assessment should be done. It is likely that the much of the damage being done to the biosphere would be irreversible. So that's why at present rate of testing, it would be take centuries to assess their long range and synergistic effect on the planet's life, let alone the near-term effects on the human health. So that's why the EPUB analysis to be done, but at the same time, management practices has to be implemented very sincerely and strongly for getting a successful result. And this is the waste management minimization strategy. Naturally, this is the hierarchy. So prevention is the most, that is the generation. Then this is the stepwise hierarchy. Okay, so disposal is the, as per the hierarchy, disposal is the last option. Okay, so with this, I thank you. So last word I want to say, the earth provides enough to satisfy man's need. So by generating hazardous waste, but not for every man's need. So that's why let us join hands to fight against this pollution with a sustainable and innovative approach. Thank you. Thank you for all. Okay, so with this, I would like to complete my presentation. So if you have any questions, you can share. Otherwise,
So, any question from your side? Dr. Bhattacharya is waiting for you. You can interact just now. Anyone from your side?
Sir, all the regulations we could not remember. Can you share?
Professor Onu.
Yes, sir.
So I shall send you the PDF file of this lecture. So don't worry at the end of this program.
Thank you, sir.
Okay,
Thank
sir.
We have lecture notes as well.
Yes,
so that will give you the what you are looking for actually.
Yes, yes. So I think there is no query. So thank you.
Sir?
Yes, please. Please.
Sir, my question is there. Is biomedical waste regulated as a hazardous waste?
It is a hazardous waste, as I am said, but it is under the biomedical waste rule. Obviously, biomedical waste is a hazardous waste, but
yes,
initially it is under the hazardous waste management rule. But now it is under the separate category. It is a hazardous waste that nowadays it is so sensitive. It is under the separate act has been generated. It is a biomedical waste. Okay, so that is a totally separate guidelines with respect to biomedical waste.
Okay, sir. Thank you, sir.
So, Professor Khan, in addition, so tomorrow we have a discussion in the morning, I mean session 1.
Yes, sir.
One doctor, medical practitioner, and
yes,
he will
sir.
deliver a lecture on biomedical waste.
Yes, sir. Yes, sir. Thank you, sir. Thank you, sir. Thank you.
So, Dr. Bhattacharya, I received one chat like, sir, whether documents required for transportation of hazardous waste between the state differ?
No. It is not differ. It is same rules applicable to every states. But as I am telling, for transportation, see it depends on the for storage facility. It is differ. Those storage. Suppose some state don't have any storage facility. They are using the other state. As I am Sikkim and West Bengal. So in that case, the Sikkim some relaxation is giving to those state having that don't have any facility. But rules, management rules, disposal rules, guidelines are same. Only with respect to storage, they may get some relaxed time and transportation. That's all.
Okay, so thank you, sir. So, Professor Dilip Patil, please unmute. Professor Dilip Patil. Professor Dilip Patil. So his question is like this. I don't know. Sir, yes, Professor Dilip Patil.
Yes, sir. Yes, sir.
So
my question is that one.
Yes, please.
Okay, sir. Am I audible, sir?
Yes, you are audible.
Okay. Sir, whatever the vehicle PUC is there, whatever the different emissions are there, the exhaust emissions, that comes under this hazardous waste?
Can you repeat your question?
Okay, sir. Vehicle PUC. Generally, we are doing the PUC for cars, vehicles, automobile vehicles after 6 months. Whatever the exhaust emissions are there.
No, that is not common. No, that is not come under the hazardous waste. You can see I have mentioned the Air Act and the Water Act. That is the separate. You can see that is come under the Air Act.
Air Act, okay. That are, but they are creating some problem.
Yes. Like, see, the vehicular emission has a guidelines. Similarly, the power plant emission has a guidelines. And in case of hazardous waste, if you going to incinerate, that has also a spec that I have already shared with you in the last slide.
Okay, sir. Thank you, sir.
So thank you, Professor Patil. So
welcome.
Yes. So if you have any query, you can ask just now. because we already passed 4 o'clock, now 4:10. So we are waiting for 4:20, isn't it? Okay, any question from your side, sir and madam?
Good evening, Professor. This is Dr. Karthikeyan from Crescent Institute of Science and Technology, Chennai. So we are talking about a lot about hazardous material. In the real time, are we have a lot of like disposal method? Are they really doing the incineration process, for example, medical waste or other wastes? Are they handling properly? And in terms of India, what is the current facts, real fact, those industries are handling the hazardous waste? Is it possible to give some input on this, sir?
Actually, what happens? Actually, the rules are very stringent now. Rules are very stringent, and it is not only since the hazardous waste is going to contaminate the water resources also. So that's why now with respect to water management also, a lot of regulations are come up. So it is interlinked. So if your groundwater management is affected by the hazardous waste.
For example, Professor, like Tirupur, we have collected some water sample. So as per the regulation, it's supposed to be less than 0.5 micro, like 0.05 microgram is a allowable limit for the dyes. But when we took a sample, this is higher than whatever the recommended level by the regulatory bodies. So I don't know what really are we implementing this kind of disposal?
Yes. Now, actually, what happens, some of the parts of India, like Tripur is known for the last 30-40 years. So, that the very well-known place for the textile dye pollution. And nowadays, it is another site, that the Ludhiana, Punjab. In the Punjab, Ludhiana. These are the two periphery in the India. So, Tripur, sometimes, that the government has stopped all the textile plants few years back, and everybody strong instruction going for ZLD. You have to go for ZLD, no single discharge is allowed. But again, there is some, see, India is a place where a lot of problem. The rules, implementation is rules is there, but somebody again we have to change our mindset also. So until and unless we have a strong mindset to change, that is where rules are there, stringent implementation also there. But due to some people's nature, so we have to change our nature. That is also another part. So it is implemented. Now it is very strong, very strong. And obviously, as you are rightly told, the authorities should be go for regular vigilance. Without any notice, they should visit the plant. So, and nowadays what happens, it is becomes not only they see the people, surrounding people now become very sensitive now. Suppose something happen now, don't bother for the pollution control board. Rural people become very sensitive now. As per my experience, I have visited one plant in Nellore. So it is a food processing. They are producing lot of glycerins and waste, oily waste. So nearby there is a total village area. On the not only the pollution control board, due to the fear of the village people agitation, they go for recycling and minimizing the discharge.
Okay.
So this is the real fact, is what is going on. So nowadays rural people are very sensitive. They will more than the pollution control board now.
Correct.
Thank you, Professor.
Thank you.
So I think there is no question. Okay, so thank you, Dr. Bhattacharya, for your valuable lecture. Thank you so much.
Thank you, and it's my pleasure.
So tomorrow again, we'll meet with you, okay, for another lecture, and that is very much important for us because waste,
liquid waste
characterization, because you have to conduct another session, that is online demonstration, that is basically based on the liquid waste characterization. So we are planning to show through camera some of the important experiments that is related to liquid waste parameter like BOD, COD, TSS, like this. Okay. So your class, your class also very much important for us. Okay. So thank you, Dr. Bhattacharya, for your valuable input in this program. So again, thank you to all of my respected professor participants. So for your patience, obviously, this is very important, and this is very important part of this program. So your patience is very, very important. Otherwise, it is not possible to continue at least from 4 to 4:15. Okay. So thank you so much. So tomorrow again we'll meet at 10 o'clock. And tomorrow's our first lecture. Don't forget it. That is related to Dr. Bhattacharya already initiated. That topic is biomedical waste. Okay. So thank you so much. So tomorrow again we'll meet at 10 o'clock. Thank you, Dr. Bhattacharya.
Thank you.
Thank you so much. Thank you all.
Thank you.